We will talk about the inequalities. For the inequalities, we have to know some basic properties or basic rules. So whenever you have absolute value of x is less than a or less than or equal to a, we can express in this form. For example, absolute value of x is less than 3 means we can say that this one, okay? If less than or equal, we can put it. But whenever we have absolute value of x is greater than 3, we can say that x is less than negative 3 or x is greater than 3. So as it is, or multiplying by a negative number, which will be greater will be less, so negative 3. So these are important things we will see in the question. So to solve this example, we can say that negative 8, and then to eliminate this one, if we add both sides plus 2, we can say that, so this is our solution. Don't forget that this is an interval, so we can express this interval negative 6 comma 10. Here negative 6 and 10 exclusive. That means it's not in this solution. If we want to graph this, if we want to show on the number line, negative 6 is here, positive 10 is here, so it's an open, and all the numbers between negative 6 and positive 10, but not includes negative 6, not includes positive 10. Now the second example. Similar to the previous one, we can say that negative 10, and since it is multiplied by 5, if we divide by 5 both sides, 10 and 5, 2, so negative 2. That's it. So how can we continue? Solution set is an interval, negative 2, comma 2. Negative 2 and 2 are inclusive. X could be negative 2 and x could be also positive 2. On the number line, how can we show this? If negative 2 here and positive 2 here, so all the numbers between them inclusive. Negative 2, positive 2. Okay? It's easy. How can you check yourself? Take any number here. For example, number 1 is here. So put it here. 5 times absolute. Yes, it is correct. Okay? Now, what about this? First of all, just let us get only absolute value by taking the negative to the other side. And then by using the rule, absolute value x is greater than 10 if and only if x is greater than 10 or x is less than negative 10. This was our rule. So if x is greater than 10, x is greater than 10. If x is less than 10, x is less than 10. How can I show this? So I can show this like this. Negative 10, first of all, it is only less, so it will be equal. Negative 10 is here. So the numbers which are less than negative 10, which means here all the numbers are here, less than negative 10, so I can show it like that better. And then the numbers greater than 10, so greater than 10, all the numbers are here. So this is our solutions, okay? Or even you can say the solution set x such that x is greater than 10 or x is less than negative 10. Even you can say first x is less than 10 or x is greater than 10. So whatever you take here, it's a solution. Let's prove this. Let's take 100, for example. Absolute value of 100 minus 2 is greater than 8. Let's check it. 100 minus 2 greater than 8. Yes, it is. If you take a number here, for example, number 1, it mustn't be solution. So absolute 1 minus 2 greater than 8. Absolute 1 is 1 minus or greater than 8? Of course not. So we are right. Now for this question, there's one minus here, but it's a mistake. Let's say minus, let me change the question. Absolute value of x minus 4 minus 2 greater than or equal to 8. So first of all, just get on the left side only absolute value, which will be greater than or equal to 10. And by using the rule x if and only if x minus 4 is greater than 10 or x minus 4 is less than negative 10. So if we have this case, x minus 4 is greater than 10, we can say that x is greater than 14. If x minus 4 is less than negative 10, x is less than negative 10 plus 4, x is less than negative 6. So how can I show this? Negatives, by the way, this is greater than or equal, so I have to say greater than or equal, less than or equal, greater than or equal, less than or equal, and then it is included in the solution negative 6. The numbers which are less than here, and 14 if it's here, the numbers greater than 14 it is here, it's a solution. Or what can you say? Solution set is x such that x is less than or equal to negative 6 or x is greater than 14. By the way, it's better to say also x is what kind of number? It's a real number. Even here we can say that, comma, x is a real number. Or you can even say here at the beginning x is element of real number. Okay, what about this? So this is, yeah, this is interesting, guys. Absolute value of anything, could it be less than negative 8? Impossible. Why impossible? Since absolute value means distance. Distance cannot be negative. I mean, in my question, this result cannot be less than negative number. To be a less than negative number, it must be negative. So we say that empty set or this. No solution. Okay, empty set. You know that absolute value of x is equal to negative 4. Is it possible? No, empty set. Absolute value is always positive or 0. It cannot be negative. I hope you understood. Now let's talk about the graphs. Which graph represents the solution set of the system of inequalities? When the graphs are given like this, it's better to take some test points and to decide. For example, if this region is a solution, for example, let me take this one, which is negative 3, 0. X is negative 3, y is 0, is in the solution. So let me check it. Let me check it. When I put it here, instead of x, negative 3, negative 2 times negative 3, plus y, which is 0, less than or equal to 4. So 6 is less than or equal to 4. Is this correct? No. So this cannot be solution. So pass it. You may pass, no need. What about here? If this is solution, so this is now x is 1, y is here 4. So 1, 4 is in the solution or not? Put it here again. So it will be negative 2 times 1 plus 4 less than or equal to 4. Negative 2 plus 4 less than or equal to 4. 2 is less than or equal to 4. Yes, this is. But it must satisfy also second one. So let us put it here. Y, which is 4, greater than x, which is 1 plus 2. 4 is greater than 3. Yes, it is. So, yes, this is the solution. This is the answer of the question. But to be sure, let us continue. For example, this one, negative 4, 0. You can take everywhere in the region. Even you can take this point, even you can take this point. Just for simple calculation, I am taking this. So x is negative 4, y is 0. Let us put here negative 2 times x, which is negative 4, and then plus y, which is 0, less than or equal to 4. Negative 2 times negative 4, positive 8, plus 0, 8, less than or equal to 4? No. And that means this cannot be solution. And then here, take any point, whatever you want. So let me take this one. So x is 1, y is 4. 1, comma 4. So when I put it here, negative 2 times 1 plus 4 less than or equal to 4. So it will be 2 is less than or equal to 4. Yes, it is. It's okay. What about when I put it here 1 comma 4? 4 is greater than 1 plus 2. 4 is greater than 3. Now, this seems also solution. But what is the difference between them? I mean, the answer is the first. If I call this is A, if I call this is D, A or D, which one? So when you look at here, the main difference is, as you've seen here, guys, here it says that we have this region in the solution, but here in this question, we don't have. Right? Am I right? Or I can say that, for example, number 0, 3, it is not in this solution, but here 0, 3 in this solution. So better to check 0, 3 then. X is 0, y is 3. So let me put it, even in the second one directly we can try. 3 is greater than 0 plus 2. Yes, 3 is greater than 2. It's satisfied. What about the first one? Negative 2 times x, which is 0, plus y, which is 3, less than or equal to 4, which will be 3 is less than or equal to 4. Yes, it is satisfied. That means these must be in the solution 0, 3. But you see that here 0, 3, it's not in the solution. So eliminate this. That means the answer is part A. By the way, without using test technique, how can I solve the same question? I mean, if I have this one, how can I draw? Simple. Let's say this is the first equation, which is negative 2x plus y less than or equal to 4. Think this like an equation question and write this 2x plus 4, and then when x is 0, what is y? Put it here 0. 2 times 0, 0, 0 plus 4, 4. That means 0, comma 4 is my y-intercept. When y is equal to 0, put it here 0. So 0 equals 2x plus 4. So negative 4 is equal to x. Divided by 2, negative 2 is equal to x. So negative 2, comma 0 is my x-intercept. So if I draw the graph here, x and y, if I say x is negative 2, y is 0, x is negative 2, y is 0, negative 2, and x is 0, y is 4, so let's say approximately here, and then this is less than or equal to, that means it's a solid, it's not dashed, so I have to draw something like this, okay? And then which side? This side, right side of the line, or left side of the line solution? Take a test point. What is test point? For example, 0, 0, let me take. It is here. So 0, 0 is in the solution or not? I just put it here. Negative 2 times 0 plus y, which is still 0, less than or equal to 4. 0 is less than or equal to 4. Yes, it is. That means this is my solution. Okay? Now, I have to do the same operation for the, for the second inequality. So, y is equal to x plus 2. So, when x is 0, so 0 plus 2, y is 2. That means 0, 2 is the y-intercept, which is x is 0, y is 2. It is here. Let's say this is 2. And then when y is equal to 0, 0 equals x plus 2. So x equals negative 2. So negative 2 comma 0 is x-intercept. So negative 2 is here. And then I have to join these two things. Now, dashed line or solid line? Since this is only greater, it's a dashed line. So let me do it. Something like that. Am I clear? Now I have to take under this line or above this line. To determine this, again, I can choose 0, 0. So 0, 0 test point, 0, 0. I put it here. Y is 0, x is 0, 0 is greater than 2. Of course not. If not, this region, it's not. So above is the solution. So now, where do I have the intersection? Where do I have the common region? I think it is so clear by looking at the graph. The common region is this part. So this part is, if we come back, you see it is here. So we learn by using classical way, or we learn by using test technique. At the beginning of the question, so you can look at the main differences by taking the test points, but you should be careful for part A and D, since these two test points are same. So you have to try something else, something unique, something odd, to determine the difference between part A and part D. Okay, let's go on for this question. So by using the test technique, let me take, for example, here, this is now 0, 0. I am free to choose everything. 0, 0 is solution or not. Y is 0, x is 0, so 0 is less than or equal to 0 times number 0 minus 2. 0 is less than or equal to minus 2, no. So this region, it's not solution, that means this is solution. It's okay for the first one. It is satisfied. What about for the second one? 0 greater than or equal to negative 5 over 4 times x, which is 0 plus 2. 0 is greater than or equal to 2. Of course not, it's not satisfied. So 0, 0 mustn't be in the solution of the second line. Yes, it is not. So it seems okay, this could be solution. This could be solution. Okay, but I changed my mind, dear students. Better maybe, eraser pen. But better maybe let us take the test point inside of the region, which is here, for example. Okay, this is the common region, even the second line, even the first line. And by the way, there is something I can directly eliminate. Part A, I just recognized. Look at, this is less than or equal to. This is also greater than or equal to. I mean, if you have equal sign, it must be solid line. What is solid line? Means something like that. Dashed line means it's something like that. So if I have only less or only greater dashed line, if I have less than or equal or greater than or equal solid line, since I have both of them equal signs, so since this is dashed line, this cannot be solution. Directly eliminate. This cannot be solution. This cannot be solution. Directly answer must be B directly. But to be sure, let's check. For example, here let me take 1 point. So this is number 4. So if I take this one, so it is, you see now, negative 2, 4. So x is 4 comma negative 2 must be in my solution. It must satisfy the inequality. And let's say it, x is now 4, y is now negative 2. For the first one I am trying, negative 2 less than or equal to 1 over 4 times x, which is 4, minus 2. Negative 2 less than or equal to, simplify, negative 2. Yes, that's it. What about the second one? Let me try. Y, which is negative 2, greater than or equal to negative 5 over 4, negative 5 over 4, times x. X is now 4, and plus 2. So simplify. Negative 2 greater than or equal to negative 5 plus 2. So negative 2 greater than or equal to negative 3. Is this correct or not? Yes, correct. Why? 0 is here, negative 2 is here, negative 3 is here. So negative 2 is greater than negative 3. That is correct. I mean, this is the solution. You see now, guys, just one simple information. If we have both less than or equal, greater than, I mean, if we have the equal sign, the line must be dashed line, both. But here it's a, I mean, line must be solid line both. But here it's dashed, here it is dashed, here it is dashed, and that means they cannot be solution. Only remaining part is part B. Okay, one more question. Now, by using this way, uh, less than or equal, so this must be dashed, and this must be solid. So when I look at, yeah, dash solid, dash solid, dash solid. So it's okay, it seems okay. I can't do anything here. But what can I do? Let me take test point. For example, what can I take test point? So let me take first of all 0, 0. 0, 0. For this one I am checking. So you see now 0, 0, it's here in the solution. So y is 0. Negative 3 times 0 minus 2. So 0 is 0 minus 2. 0 is less than negative 2. It is wrong. So this cannot be solution. So 0, 0 it's also here. So this cannot be solution. So I have two alternatives. This one or this one. So what is the uniqueness it's here? You see that they are both, it seems they are both same. But the difference is I think here. This is negative 1. This is the root is between negative 1 and 2. Here the root is between 0 and 1. This could be one of the difference. As a region, when I look at here, it includes something here, but it doesn't include this part almost here I have. What is the difference between them? Just the difference between them is here. How can I explain? Negative 2, it's there. Yeah, it is on the y-axis, you see, but this dash line, it's not on the, for the dash line, y-intercept is negative 3. Y-intercept, negative 3. What about here? Y-intercept for the dash line is negative 2. Y-intercept. So, a dash line is this one. How can I find the y-intercept? It's so easy. Y is less than negative 3x minus 2 to find the y-intercept. You know, think this is equation. Say it when x is 0, what is y? So y is equal to negative 3 times 0 minus 2. So y is equal to 0 minus 2. Y is equal to minus 2, negative 2. So negative 2, is it the negative 2? No. So this cannot be solution. Is it negative 2? Yes, this is solution. It's finished. So elimination method. If I use the classical way, guys, if I use the classical way, let's do it. So y is, let me change color. Y is, let's say, negative 3x minus 2. And when x is 0, so put it 0, 0 times negative 2 is 0, 0 minus 2, minus 2. Y is minus 2. And then when y is 0 here, take the negative to other side, positive 2, and divide negative 3. So it will be y is equal to 2 over 3, but it is negative. So negative 2 over 3. Let's check one more time. When x is 0, y is negative 2. When y is 0, take this one other side. It's okay. So the number is 0, comma, negative 2 over 3. And then draw it. And do not forget, this is only less, so it will be dashed line. So x is 0, y is negative 2. X is 0, y is negative 2. So it is here, let's say somewhere. And then x is 0. Did I make a mistake here, guys? X is 0, y is negative 2. And y is 0, this is x. Yeah. Here, this is x. Why? We have calculated this one. When y is 0, what is x? We said. So y is 0 here. And x is negative 2 over 3. So where is it negative 2 over 3? Let's say approximately here. X is negative 2 over 3. And y is 0. And this is the dashed line. This is my line. And so when you look at the alternatives, negative 2, yes, it could be. Negative 2, it could be. This is not negative 2, so this is not solution. This is not negative 2, so this is not solution. There are two cases. Even after this case, you can say that when you look at the graph, 0, 0 here in the solution, 0, 0 here, it's not in the solution. By checking 0, 0 as a test point, you can decide. Okay? But since we are using the classical way, not test technique right now, let us decide now. Right side I have to shade or left side. To do this, take a test point. Test point 0, 0 let me take. And so, for this line, 0 is less than negative 3 times 0 minus 2. 0 is less than negative 2. Is this correct? 0 is less than negative 2? Of course not. So this mustn't be in solution. So the solution must be this case. Okay? And then, let me change the color. We are looking for the second. Y is equal to x minus 2. So when x is 0, it's clear that y is negative 2. And when y is 0, x is positive 2. So x0, y is negative 2. So it is same point. And then x is 2, y is 0. X is 2, so it will be somewhere here, y is 0. And it's an equal sign. That means directed dashed line. Now, I have to decide right now. So you see now, this one and this one, which is here. Now, I have to decide right now, where is the solution? It's on the left or on the right. So to do this, I can take a test point. So test point. What is the test point? 0, 0 again. So if 0, 0 is in the solution, I will shade left side, if not right side. So my function is y is less than or equal to x minus 2, 0 is less than or equal to 0 minus 2, 0 is less than or equal to minus 2. Is this correct? What do you think 0 is less than or equal to negative 2? Of course not. It's wrong. So 0 mustn't be in the solution. That means left side mustn't be. So right side here. So now where I have the common region, which means the common region, intersection of given two inequalities, of course this part is the common region. So where is it? It is here. So this is the solution. I hope you understand. So you can make a comment. If you have any question, I can try to answer it. If you like the video, you can like it, dislike it. All the best, guys.